Right, so let's go to the second one, which is cam. Okay, cam and follow. So cams is normally we can see it in the normal type is in engine, or we can see it into machine and letter machine. So cam actually consists of the cam itself, the one that is going to rotate, and you have the follower. It's similar. It looks similar to the slider and crank mechanism. But slider and crank mechanism, we have the linkages, which is connected to both the slider and the crank shaft. But for cam is that it's not connected indirectly, but it's going to touch. Okay, you can see that this cam is touched with this follower, right? So when this cam rotates, then this follower will move up and down. Right? So cam is a body which rotate or oscillate, and in doing so, impart a reciprocal motion to a second body called follower. So macam yang I explain tadi lah, cam is going to rotate and it impart the second part, which is the follower, to move in linear motion. Okay? So it divides into three parts for the cam. We call it as the fall, rise, and wheel. So part that lowers the follower, its profile determines how quickly the cam follower will fall. So imagine that when you actually the cam is actually rotate in this position. Okay, this is cam right now. So imagine that it's rotate in this position, and then you have the follower is going to move down. Sorry, not a good drawing. I'm using the mouse. So the follower actually move up and down. Okay, based on the rotation of the cam. Okay, so means that the important one is what the shape of the cam is really important. So shape of the cam determines the motion of the follower. So you can see later on why in the engine car, the cam and follower have a specific design. The cam have a specific shape. It's because you want to imagine that just now, at one point, 1 second point, at this point, for example, the motion of the cam and follower at this point, sorry, slope, at this point, you want the valve to open for 1 second. For example, this is a 0 second, this 4 second, 5 second. So 1 second open very fast, or 0.1 second it opens. So at this peak, the valve will open, and after that, it will close. Okay, so it means that how actually to make this motion using cam and follow. So let's look at how it's going to be used to make a motion. So, but before that, let's look at the type of cam that you can use. Cam and follower. So we have the point, knife, and roller here. So point means that you have the follower is in terms of a point, knife. That is actually very pointy, and then roller, you have a roller type. So of course, normally but not in the engine but roller normally it's used for production and manufacturing production. So it's using this one because it has lower friction, because easy to maintain compared if you have the point or knife. Of course, you can use point and knife in the cam and follower, but you need to make sure that the contact between the cam and follower has low friction. Okay, low friction means that the material need to be having a low friction, surface friction. And next is that we have the slider and oscillating, flat and mushroom type. So normally, if user they normally want a point type or knife type, they will go for the flat type because it's more cheaper and easier to actually fabricate. So this one, if you later on for IDP project or even for PSM project, you can actually make your own cam and follower. You can use 3D printer. 3D printer to print out this cam and print out the follower, and just attach the motor to the shaft. Then you can actually rotate the cam and look at the positioning. Okay, so this example where you can use these devices. So how to actually make a motion out of this cam and follower? Okay, the cam shape required to produce a particular motion of the wheel will depend on the shape of the cam and type of follower used. So shape of the cam is this. This one is the cam, the one here. You see here. So if you see here, the radius is not the same. You have this radius is much more larger than this part F. So it has a specific shape. Okay. So this specific shape actually will give this motion. We see here it give a single harmonic motion, means that at this one it's going to have a kick motion. And it means that every time it moves, it's going to rotate. So you can just look at this graph and find out, oh, okay, this one at 180 degree. Actually, you can look here is that at the point where the radius is the maximum point. Okay. And for the lowest peak is that you have the point where you have the radius is at the smallest radius. So therefore, you can get this type of waveform or motion. So the commonly used type of cam, okay, that we have is the heart-shaped cam. Okay, it looks like a heart because it's like this. Okay, and you have the pear-shaped type. So pear-shaped type is like a pear lah. Okay, pear. It's not circle. Exact circle. It has a distinguished design. So normally this pear type shape, you use it in the engine. Okay, in engine, the way that you inject the spark plug, and the spark plug where it's going to inject at that point is going to open the valve. So this is where you will open the method to open the valve at this point.